Hello, Integrated Math 1. Welcome to lesson 2.3.3a. So we're on topic 2, module 2, topic 2. I can say this, module 2, topic 3, lesson 3. And we're just doing the first half of the lesson today. So we're doing day A, day 1, however you want to think of it. But we're going to do activities 3.1 and 3.2 in our book today, starting on page M2-189. So we've been talking about inequalities, and we've done inequalities before. They're not new to us. This isn't a foreign thing, but typically we've only had inequalities with one variable, right? We solve for x, we figure out what x is greater than, equal to, less than, any of that good stuff. And then when we graphed it, we just put it on a number line. But we're taking it to the next level. So now we're going to be dealing with inequalities with two variables, an x and a y, more than one variable in it, and that changes things. That changes things quite a bit. But to introduce us to this idea, let's talk about playing some basketball, shall we? So Coach Purvis is analyzing the scoring patterns of players on his basketball team. Benna is averaging 20 points per game from scoring on 2-point and 3-point shots. She's got some skills there. We'll give her credit for that. So I would like you to go through and answer questions on number 1, answer parts A, B, and C. If she scores this many points, this many shots, is she going to meet her per game average of 20 points? So go ahead and hit pause, work it out for A, B, and C, and let's see if she's going to hit her average. And then hit play when you're ready to check your work. So she scores 6 2-point shots. Okay, hang on, I need my pen here. So she's going to score 6 2-point shots. So 6 times 2 will be her 2-point shots. But we're going to add on 2 3-point shots. So we'll pop that in there. Well, 6 times 2, of course, is 12. 2 times 3, of course, is 6. And 12 plus 6 gives us 18. Ooh. Yeah, if she scores 6 2-point shots and 2 3-point shots, she will not be meeting her average. That is simply not going to happen. Yeah. Boo. So if she scores 6 2-point shots and 2 3-point shots, no, Benna will not meet her 20 points per game average. But of course, we have option B, right? If she scores 7 2-point shots plus another 2 3-point shots, well, 7 times 2 is 14, 2 times 3 is 6, and 14 plus 6 is 20. Ooh, so yes, actually, if Benna scores 7 2-point shots, there we go. If she scores 7 2-point shots and 2 3-point shots, she will meet her 20 points per game average. So good for you, Benna. And of course, we have a third situation here. So let's say she's still going to be scoring 7 2-point shots, but now she's upped her game a bit here, and she is scoring 4 3-point shots. Way to go, Benna. So 7 times 2 is, of course, 14, plus 4 times 3, which is 12, and 14 plus 12 gives us 26. Ooh, way to go, Benna. So what this means is she won't just meet it, right? If she scores 7 2-point shots and 4 3-point shots, she'll actually exceed her 20 points per game average. Well done. Well done. All right, so we've just been playing with this and plugging things in. Can you actually write an equation now? Can you write an equation with an equal sign to represent the number of 2-point shots and the number of 3-point shots that would total 20 points? Make sure you tell me what your variables represent, all that good stuff. So go ahead and hit pause, write your equation, and then hit play when you're ready to check your work. So I'm going to use x and y, and I'm going to let x represent the number of 2-point shots, and then I'm going to let y represent the number of 3-point shots, just so I know what x and y are. So of course, 2-point shots are 2 points each. So we'll do 2 times x. My pen here. So 2 times x. And of course, 3-point shots are 3 points each. So we'll add 3 points for every 3-point shot. And of course, we want it to equal 20, right? They did say to write an equation. We've written an equation. Hooray! Good job, us. Yay. Let's graph it. Shall we graph it? Here, I'll bring my equation back up again. Let's graph it. I would recommend finding the x-intercept and the y-intercept, probably be the easiest way to graph it. Also, make sure you label your graph. Do you notice the graph isn't labeled? So make sure that you label your graph as well. That'll make things better. Go ahead and hit pause to work this out and graph your equation, and then hit play when you're ready to check your work. All right, so I'm going to start by finding the x-intercept. You guys know that in order to find the x-intercept, all you got to do is set y equal to 0. So fine, 2x plus 3 times 0 equals 20. And of course, 3 times 0 is 0, so that kind of dies, which is why we did it. We have 2x equals 20, and we'll divide both sides by 2. So I find out that x equals 10. Hooray. So my x-intercept is 10. So I'm going to go ahead and label here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to keep going because, you know, I can. Oh, no. Only if my pen plays nice. Play nice, little pen. 12, 13, 14, 15, on and on and on. You get the idea. And of course, my x-intercept is 10, so it should hit my x-axis. Boom, right there, right at 10. Come on, little guy, you can do it. Good job. Now, of course, I have found that finding the y-intercept is also super helpful here. So let's go ahead and find our y-intercept. Hooray. We said in order to find the y-intercept, well, I need to plug in a 0 for x. So 2 times 0 plus 3y equals 20. And of course, 2 times 0 is 0, so that's gone. 3y equals 20, so I'll divide both sides by 3. So I get y equals 20 thirds, but since I have to graph it, I'm going to go ahead and divide it out and do it as a mixed number. 3 goes into 26 times. 3 times 6 is 18. 20 minus 18 leaves me with 2 leftovers. Yeah. So I get 6 2/3. So I'm going to go ahead and label my y-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I mean, we could go forever here. We're not going to go forever. We'll go a little further. Oh my gosh. Just as I say that, that's when my pen decides not to cooperate. You can do a little pen. 13, 14, 15. All right, we don't need to go forever and ever. So it looks like my y-intercept is at 6 2/3. So I'm going to go up 6. I'm not going to quite get all the way to 7. I'll get close to it. I'm just going to put a little dot right about there. Fair enough. Oh, and of course, we are graphing an equation, which means I do need to actually connect the dots. So let's go ahead and do that. We shall connect the dots. I'm going to use my computer to help me do that. Make a nice straight line. It'll work out better that way. And I'll be all like, there's my line. My line's a little off. That's all right. That's all right. Erase all my stuff over here so it's prettier. Sorry, I like it to be pretty. I don't know what to tell you. I want it to be pretty. There's a typo over here too. Do you see my typo? Do you see my typo? That should be at 2/3. There's a typo. Easily fixed. Oh, look, now it's a 2. Yay. So we've graphed our equation. Hooray. Now, we're going to be coming back to this graph an awful lot. So I know that we got to flip the page. I know that we're going on to other questions and other things, but we are going to be coming back to this page over and over and over again. So keep that in mind that we're going to be flipping back and forth here quite a bit because we're doing a lot with this graph today. All right. Now, Coach Purvis believes that Danvers High School can win the district playoffs if Benna scores at least 20 points per game. So, how can we rewrite the equation that we wrote on question 2, that equation we've been using, to represent that Benna must score at least 20 points? Can you describe for me how you could rewrite the equation to represent this better? Go ahead and hit pause, just write down your thoughts, and then hit play when you're ready to keep going. Okay, so we want to rewrite the equation to represent that she needs to get at least 20 points per game. So equal to 20 points is good. More than 20 points, also good. Okay, so we don't want it to be less than, that's the one thing. So we do want it to be greater than or equal to. Is that giving you some ideas? So the equation must be rewritten to show that the 2-point baskets and 3-point baskets that Benna scores must be equal to or greater than Benna's 20 points per game average. So with that in mind, write that inequality. Write the inequality. It is an inequality in two variables because we have an x and y in it, but write the inequality that represents the situation. Go ahead and hit pause, write it down, hit play when you're ready to keep going. So that just means we've got our 2x plus 3y, but we're now saying instead of being equal to 20, we're saying that it can be greater than or equal to 20. She scores more than 20 points, that's a good thing for our team. It's not so good if she scores less than that. So we'll put greater than or equal to 20. That makes things good. And what I'd like you to do now is complete the table of values, okay? Now there's a few steps here. First, complete the table, right? Fill in the table. If she scores 4 2-point shots and 1 3-point shots, what's the total number of points she scored? So you're going to start just by filling in this lovely table, okay? If the number, and what you're then going to do is notice it says then add the ordered pairs in the table to the graph. That graph we were just doing on question 3. So think of this as though these are your x coordinates and these are your y coordinates, all right? So think of these as though these are your x coordinates and your y coordinates. So once you've completed the table, plot each of these points, okay? Plot each point. And I want to point something out. I want to point something out. Do you get it? Hilarious. If the number of total points scored does not meet or exceed Benna's points per game average, right? We don't make it to that 20 points per game. Then what you're going to do is when you plot it, instead of a dot, put a little x. Put a little x, okay? If the number of total points scored meets or if it does meet the 20 point or it goes over the 20 points per game average, use a dot. Put a little dot when you plot the point, okay? Go ahead and hit pause, fill in the table, plot the points with X's or dots, depending on if they made it or if they didn't, and then hit play when you're ready to check your work. All right, so first of all, for every single one of these, you're going to have to multiply by 2, right? Multiply by 2, multiply by 2, multiply by 2, multiply by 2. These are all 2-point shots. These are 3-point shots, so everybody here is going to get multiplied by 3, right? We're going to multiply all those guys. And then, of course, we have to add them together. No problem. 4 times 2 is 8. 1 times 3 is 3. 8 plus 3 is 11. So that's going to be an X. Yeah, when we plot that, we did not make it to 20. 6 times 2 is 12. 1 times 3 is 3. 12 plus 3 is 15. Still didn't make it. So when we plot that point, that one will also be an X. 7 times 2 is 14. 1 times 3 is 3. 14 plus 3 is 7. Still didn't. We got closer, but yeah, still didn't quite make it to 20 there. 8 times 2 is 16. 2 times 3 is 6. And 16 plus 6 is 22. Oh, that one made it. So when we plot this point, we're going to make a dot. I'm just making notes here to help me when I go to graph these things. 6 times 2 is 12. 4 times 3 is 12. 12 plus 12 is 24. Oh, so that one's also good. So when we go to plot that point, we're gonna make it a dot if I can make my dot work. And last but not least, 9 times 2 is 18. 5 times 3 is 15. 18 plus 15 is 33. Benna was having a good game that day. So that one's also going to be a dot because we went over our 20-point average. Now, I'm going to scroll back a few pages here, so you have to pardon me for a moment. I'm going to scroll back several pages to get back over to the graph. Let's come back to our graph. Here's our graph. Now, let's plot each of our points. The first point is 4, 1, right? 4 2-point shots, 1 3-point shot. And if you wanted to, you can even be like, these are the 2-point shots. Like maybe you could put that there. 2-point shots. And then for our y-axis, will be like, these are 3-point shots, right? It always helps to label stuff. All right, so 4 2-point shots and 1 3-point shot, and we're going to put a little X because that didn't make it to 20. 6 2-point shots, 1 3-point shot, and again, we're putting an X because it didn't make it to 20. 7 2-point shots, 1 3-point shot. Again, I'm making a little X because we did not make it to 20. The next one did though, right? 8 2-point shots, 2 3-point shots. That one's getting a dot because it made it. We got there. Yay us. 6 2-point shots, 4 3-point shots, and we're putting a little dot because on our table it went over 20. And then we're going to do 9 2-point shots and 5 3-point shots. And again, that one gets a dot. Oopsie, come on, baby. That one gets a dot because it went over 20, so we're all right there. Do you notice something here? Look at where our X's ended up and look at where our dots ended up. Interesting. Let's use that then to help us. Oh, here we go. We'll get there. To help us answer question 6. What do you notice about your graph and where your dots and your X's went? Go ahead and hit pause, jot down what you notice, and then hit play when you're ready to keep the discussion going. So I don't know about you guys, but I noticed all the dots, the points that exceeded Benna's average, were above the line. And all the X's, the points that didn't exceed Benna's average, were below the line. Did you notice that? Did you notice that? So what can that tell you? How can you interpret that about the solutions of the inequality from the graph? What are you noticing? Where do you think solutions are going to end up when in terms of that inequality in the graph? Hit pause. I don't think I worded that well. Hit pause. What can you interpret about the solutions of the inequality from the graph? Hit pause, write it down. Hit play to keep the discussion going. So I noticed that the line almost became like a boundary line, right? Between the points that are solutions and the points that are not solutions. So that's what I wrote down, that the line was like a boundary between those that are solutions and those that are not solutions to our inequality. Go ahead and go back and choose a different ordered pair. So we had a couple ordered pairs that we plotted. Can you go back and pick a spot on your graph, an ordered pair on your graph that's located above the line, and pick an ordered pair, one that we haven't already done, that's below the line? And how do these points confirm your interpretation of the situation? And explain your thinking on that. Go ahead and hit pause, work this out, pick a couple points, one above, one below, and then hit play when you're ready to keep the discussion going. All right, so again, I'm going to come back all the way back to my graph, coming back. There it is. Woo. So I'm coming back to my graph. We said to pick a point above and to pick a point below. So I'm going to pick a point above. That point looks good. What is that? 5, 7? Or no, 5, 6. It's 5, 6. So I'm going to pick 5, 6, and then I'm also going to pick a point below the graph, 2, 2. Sounds great. So we're going to pick 2 points here and see what we discover. So I picked 5, 6, and I picked 2, 2. We said this one was above. And we've noticed up to this point, our solutions have all been above. And then I picked this one, which is below, right? And we've noticed that the ones that didn't meet the 20-point goal were below. So let's see what happens if I actually work this out. So if I did 5 2-point shots plus 6 3-point shots, well, 2 times 5 is 10. 3 times 6 is 18. I should point out, you probably picked different points, and that's okay. Your work's going to look a little different than mine, that's all. And 10 plus 18 is, of course, 28. So this is a solution, right? This is totally a solution because it's greater than 20. But if I pick 2, and I plug in for x and I plug in for y, so 2 times 2, 3 times 2, 2 times 2 is 4, 3 times 2 is 6, 4 plus 6 is 10. 10 is not greater than 20. So this guy is not a solution. So this kind of backs up what we were noticing. It looks like all of our solutions are going to be above the graph, and anything that's not a solution is going to be below the line. I feel like we've hit on something here. So what I'd like you to do, we're saying that the one side of the line, everything above the line is a solution. So what I would like you to do is, can you go back to the graph? And I would like you to shade the entire side of the graph that contains the combinations of shots that are greater than or equal to Benna's points per game average. I'd like you to shade the side of the graph that has all of our solutions. Go ahead and hit pause, go back and shade your graph, hit play when you're ready to keep this going. All right, again, I gotta go back. I'm going way back. There it is. Woo, too far. So I've come back here to our lovely graph, and we were noticing all of our solutions were above the line. So I'm gonna shade everything that's above the line. I'm gonna shade everything above the line, all right? You can use your pencil and just shade it. This yellow I picked is so light that I can't even see it, but there you go. So we're gonna shade everything over here. We're gonna shade it all. Shading. Coloring, woo-hoo-hoo, we're coloring. And we're gonna shade all of it. All of these are solutions, aren't they? Every single one of these are all solutions. Oh my gosh, so there's so many different combinations that Benna can get. Oh, here, I'm gonna shade closer to the line. I feel like I'm leaving out these guys. You're not left out, we love you too. I'm gonna shade these in too. It's important to shade everybody in. Usually we think it's not nice to throw shade, but today it's a good thing. Yeah, so we've shaded in the whole side of the graph. Check it out. That's a lot of our graph. That's a lot of solutions. It's a lot of possible combinations of 2-point shots and 3-point shots that Benna could throw to hit her 20-point average per game, 20 points per game average. Yes, I can say it. I'm getting there. We're getting there. All right, one last little thing. So we've shaded our graph. Good job, us. One last little thing. How are the solutions of the linear equation, 2x plus 3y equals 20, differ from the solutions of the linear inequality, the 2x plus 3y is greater than or equal to 20? How are these solutions different? Hit pause. Write down your thoughts and then hit play when you're ready to check your work. So we've said in the past that the solutions for a linear equation is any point that's on the line, right? We said any point that's on the line is a solution of that equation. So when we're dealing with the linear equation, it's any point that's on the line. But now when we had the inequality, suddenly there were so many more solutions, right? The solutions of the linear inequality includes half of the coordinate plane, literally the entire half of the coordinate plane that was above our line is a possible solution now. So it's interesting. Solutions for a linear equation are just points that are on the line. They have to be on the line. But the solutions of a linear equality include that entire half of the coordinate plane with that line serving as a boundary for us. So now I have one last little thought for you. Does the ordered pair 6.5, 5.5 make sense as a solution in the context of this problem situation? Explain why or why not. Hit pause, write it down, hit play when you're ready to keep the discussion going. 6.5. You guys remember what these stood for, right? You remember that X, oh, I need to change my color back so I can see what I'm doing again. Remember that X was the 2-point shots, right? 2-point shots. And Y, that was our 3-point shots. You remember that's what those were, right? Can you make half a shot? I mean, I don't know if you've ever played basketball, but can you like make a half a 2-point shot or a half a 3-point shot? I don't think so. So no, an ordered pair like 6.5, 5.5, that doesn't make sense in this problem context. Bennett can't score any partial baskets. There can only be whole numbers of 2-point and 3-point shots, right? You score a basket or you don't score a basket. There's no like halfway. Although sometimes you come close and you cringe a little bit. You get the idea. So like linear equations, linear inequalities, they do take different forms. We do seem to be partial to the standard form these days, and that's okay. But each of these linear inequalities in two variables represents a different relationship between the variables, right? This means everything less than C. This means everything that's greater than C. This means it's everything that's less than or equal to C. This is everything that's greater than or equal to C. So there's a different relationship happening with each of these inequalities. And we really need to start taking a closer look at that. So the graph of a linear inequality in two variables is literally half the plane, right? It's half of the entire coordinate plane. So we say the graph of a linear equality is a half plane, that we just shade the half that applies to us. But of course, we know there's a boundary line, right? We do understand that there's a boundary line. So the boundary line, and by the way, you notice these are bold. These are some key terms for you. The boundary line is determined by the inequality, all right? And then it divides the plane into two half planes. And the inequality symbol indicates which half plane contains all of our solutions. And these solutions we represent by shading in the appropriate half of the plane, all right? Now, I want to point out something very key, very important here, and I hate that they made it in this tiny little box off the side because it's important. If the inequality symbol is less than or equal to or greater than or equal to, it has that little half of a squashed equal sign down there, the boundary line is solid, okay? Because all the points on the line are part of the solution, right? The line is equal to, so they are solution as well. But I'm also going to point out, I'll use a slightly different color here. If the symbol is less than or equal to, notice no squashed equal signs now, the boundary line is a dashed line because no point that is on the line is a solution, all right? So if you have, remember that whole open circle, closed circle when we did the number lines? Think in terms of that. If you have a little half equal sign, a little squashed equal sign, less than or equal to, greater than or equal to, then when you make your boundary line, it will be solid. If you don't have those little half equal signs, you just have less than or equal to, open circle, right? Then that means our boundary line is going to be a dashed line. So when we draw our line, we'll be like 2, 2, 2, 2, 2, 2, 2, and we'll make little dashes. Super important to notice. So we're going to consider the linear inequality y is greater than 4x minus 6. So this means that the boundary line that divides the plane is determined by the equation y equals 4x minus 6. So if you want to know how to find your boundary line, fine, put an equal sign in there and that'll help you graph your boundary line, okay? But let's answer a few questions. Before we make our boundary line, let's make sure we answer some important questions. Question number 1, should the boundary line in this graph be a solid line or a dashed line? Explain your reasoning. And if you got to go back. Here's our little inequality. Y is greater than 4x minus 6. Dashed line or solid line? Tell me why. Hit pause, write it down, and then hit play when you're ready to check your work. Well, I don't know about you guys, but I noticed that this lovely little guy does not have a squashed equal sign. That is a greater than symbol. There's no equal to there. So because the symbol is greater than, the line is not included in the graph. Therefore, it should be represented by a dashed line. So when we go to graph our line, we need to make sure that we make it a dashed line. Dash it all. It's fine. So go ahead and graph it then. Now that you know you're supposed to be graphing a dashed line, here's our inequality. Go ahead and graph our dashed line. Hit pause, graph your dashed line, hit play when you're ready to check your work. All right, so we know it's a dashed line. We know it's the dashed line at y equals 4x minus 6. So we know how to make this line. We can do this. I'm going to grab my other pen. So we know that this is our slope. You know how this goes. We know that this is our y-intercept. You know how this goes. So this means it should hit my y-axis at -6. So 1, 2, 3, 4, 5, 6. There it is. Hooray. We also know the slope is 4, or if you want to think of it as 4 over 1, since that is a whole rise over run thing. So from here, we will go up 4, 1, 2, 3, 4, and we'll go over 1. And of course, we are making a dashed line. Again, you might want to use a ruler or a straight edge of some kind to do this, because you're about to see what happens when you don't have a ruler or a straight edge of some kind to do this, and it's not pretty. It's not pretty. Oh my, what happened? That's not what I wanted. I'm hitting weird buttons. There we go. So we went up 4 over 1. There we go. Put my 1, 2, 3, 4. Yeah, 1 over 1. So let's go ahead and connect the dots with a dashed line. It's not going to be the prettiest thing ever, but we'll make it work. So here's my dashed line. And we'll make it all dashed. So notice it's not solid. It's dashed. Okay, not the best ever. So yeah, if you have a straight edge, it'll make it a lot easier to do your dashed line. My dashed line isn't very good, but you get the idea. So here's my dashed line. Yay! Now, here's the trick though. Here's the trick. We've made our dashed line, and we know that since it's an inequality, we need to shade one side of this line. But the question is, which side? That's a big question, right? So here's what you can do. After you graph the inequality, whether you have a solid line or a dashed boundary line, either way is fine, you need to decide which half plane to shade. So to make your decision, consider the point 0, 0. If 0, 0 is a solution, then the half plane that contains that 0, 0 should be shaded. If 0, 0 is not a solution, then the other half of the plane should be shaded, the half of the plane that does not contain 0, 0, okay? So here's what you're going to do. First of all, you have to decide if this is a solution. Here's a hint. That's X. That's Y. You could, plug in and find out. So for part A, we have a couple parts to this. I would like you to decide if it's a solution and explain why it's a solution. And of course, if it's once you've decided whether or not it's a solution, that's going to tell you which side of your graph to shade. So once you've decided whether or not it's a solution, go back to the graph on the previous page and shade in the half that's supposed to be shaded. All right, go ahead and hit pause to work this out for A and B, and then hit play when you're ready to check your work. All right, let's figure out if it's a solution. So let's plug in. Instead of a y, I'm going to plug in a 0. Instead of an x, I'm also going to plug in a 0. Of course, 4 times 0 is 0. 0 minus 6 is a -6. And yes, 0 is greater than -6. So this is a solution. Hooray! All right, so that means it's shading time. Time to throw some shade, people. So let's come on back here. 0, 0 is over here, and we said, yep, that's a solution. So that means we need to shade everything on this side of our inequality. So you can just shade lightly with your pencil. I'm going crazy with my little yellow highlighter over here. Coloring, woo-hoo. Ooh, we're coloring. You guys get to color a lot today. Isn't that nice? What a color. So we're going to shade it in. Shady is so shady. We're going to shade in this entire half plane. It's the entire half of the plane that's on the same side as that 0, 0. Yay for us. So that's just a quick and easy way to figure out which side of the plane you need to be shading. And of course, if we'd plugged in 0, 0 and it hadn't worked, no big deal. We just would have shaded the other side of our plane and no big deal. That's actually quite nice. That wasn't very hard at all. That wasn't very hard at all. I love it. That's good. So we shaded the correct half of our plane. All right, with this in mind, here's what I would now like you to do. I would like you to match each graph to the inequalities, all right? Now notice D is blank. So what's gonna happen is you're gonna match A, B, and C, and whichever one of these you didn't get to match, you're going to graph it on part D, okay? So go ahead and hit pause, see what you can do with this, and then hit play when you're ready to check your work. All right, are you ready to do this thing? I'm ready to do this thing. Get my pen back. All right, so I'm taking a look at my graphs. This is a dashed line. The fact that this is a dashed line tells me it's one of these two guys, right? Dashed line means no half and equal sign, so it's one of these two. But which one is it? Well, we said to use 0, 0 as our decision maker here. So we're gonna say 0, 0 is the decision maker. So I'm gonna plug it in. These all have y and 1/2 x minus 3. So let's see, I've got 0. I've got 1/2 times 0 and minus 3. Of course, 0 is 0. That's not gonna change. Half of 0 is still 0, and 0 minus 3 is negative 3. 0 is greater than negative 3. So here's what this means. This means this should be shaded above. This one should be shaded below, right? Because here's 0, 0. So for this guy, it should be shaded above. For this guy, it should be shaded below. These guys agree. Oh, these guys agree as well. They both have a greater than. So this one's also going to be shaded above. But these guys don't agree. So this one must be shaded on the other side below. All right. So here we have a little dashed guy. So I know it's one of these non-squashed equal signs. Oh, and it's shaded above. So it looks like this guy goes with A. Ooh, this one has a solid line, which tells me it has to be one of the greater than or equal to or less than or equal to. It has to be one of the guys with the half and equal sign. So, oh, and it's shaded below, and we said below means it's this guy. So it looks like this guy is graph, oops, sorry. This guy is going to be graph B. And here we are back to a dashed line. So it's one of these. It's shaded below. We did not shade in 0, 0. So that means C must be this one right here. And that means that we need to graph this guy on D. So D, let's graph this for D. I have a y-intercept at negative 3. 1, 2, 3. Do, 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 do. I have a slope of 1/2, so we're going to rise 1 and run 2. And, ooh, solid line. That needs to be a solid line. So let's make a nice solid line. I'm going to make a nice, oh no, I was going to make a nice solid line. I already messed it up. Oh my gosh. It won't erase it. That's so sad. Why did it do that? So let's make a nice solid line forever and ever that way. Forever and ever that way. Not my best. This is why I generally recommend using a straight edge, definitely. And of course, we noted earlier that it should be shaded above. So let's shade everything above. Drop in some shade. Oh yeah, and we shade all of it. Don't be slack, shade it all, man. Don't be leaving off bits. These are all solutions. So many solutions. They're all solutions. Yeah. They're all solutions. Wow. How'd you do? That's pretty good for me. And now we've got a whole bunch of these that I just want you to graph. So question number, we're number 5. We are, oh my gosh, we're all the way over on number 5. So I'd like you to graph each of these on A, B, and C. Go ahead and graph all of these lovely equations. Remember to pay attention to whether it's a solid line or a dashed line. Remember to pay attention to whether plug in 0, 0 to figure out if you should be, which side of your boundary line you should be graphing on, shading on that too. Go ahead and hit pause to work these out and then hit play when you're ready to check your work. All right, are you ready to graph? Let's do this thing. So first of all, I see that it's going to be a dashed line, so I'm gonna make a quick note of that. No squashed equal sign, so that's the first thing I noticed. That helps me out a little bit. And of course, we're gonna graph y equals x plus 3 as a dashed line. Keep in mind, there is a 1 in front of that x. You don't always see it. You can even put 1 over 1 if you wanted to. So my y-intercept is 3, and my slope is up 1 over 1. And now we're just going to make a dashed line. Dash, 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 dash. And forever and ever in both directions. Oh, yeah. Oh, wow. They got okay, we got a little wobbly there. Put arrows on either end. Now, the real question is 0, 0, right? That's the question right there. So let's plug it in. Let's figure out if it's a solution. So 0 for y, 0 for x. And of course, 0 plus 3 is 3. I don't know why I needed to write that a second time. We already know that. So 0 plus 3 is 3. And 0 is not greater than 3. That is not a solution, which tells me I should not be shading where my 0, 0 is. We need to shade on the other side. So I'm not shading where 0, 0 is. I need to shade on the other side. So we're going to shade like crazy all over here. Your shading hopefully looks better than my shading. My shading is very shady. You get the idea. Beautiful. Let's go to part B. So for part B, again, I see a squashed equal sign. So that tells me this bad boy is a solid line. Oh, yeah. So my solid line, and I'm going to graph the line. That's a negative 1/3 x plus 4. Don't forget the negative. So I have a y-intercept at 4, and my slope is negative 1/3. So I'm going to go down 1 over 3. Woo. So down 1 over 3, if I can make my pen stick. I did eventually. Oh, and of course, we said it was going to be a solid line. So let's make that a solid line. We connect the dots. Connect the dots. La, 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 la. Not my best line. La, 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 la. Ooh, there we go. So there's my nice solid line. Of course, we need to know which side to shade. So we're going to plug in 0, 0. So I have 0 less than or equal to negative 1/3 times 0 plus 4. Negative 1/3 times 0 is 0, so that's gone. And actually, yes, 0 is less than 4. That is a solution, which tells me I need to shade on the side of my origin. So I'm going to shade that whole side. Shade it all. Shade it all. We're going to go crazy over here. Crazy. Just shade everything. Ooh, look at the color. That's nice. All right, it's not very nice. Oh, whoa, my shading went totally nuts. That's crazy now. Now we're just being silly. Yay, we shaded. Good job. Last but not least, this one got tricky. This one got tricky, but nothing we can't handle, okay, people? Nothing we can't handle. We got this. So let's go ahead and graph this inequality. I can see it's going to be a dashed line. No half and equal sign, so it's a dashed line. Good to know. And we're going to graph this line. Now, you have a few options here. You could get the y, solve for y, get y alone. You could find the intercepts by plugging in zeros. That would be okay. So for my x-intercept, I'm going to make y equals 0. So I have 2x minus 0 equals 4. So 2x equals 4. If we divide by 2, that means that x equals 2. So I have an x-intercept at 2. Of course, if I want to find my y-intercept, we do it all again, only this time we say that x equals 0. So 2 times 0 minus y equals 4. That's gone. And if we divide both sides by a -1, that'll cancel out my negatives for a positive y. And 4 divided by a -1 is a -4. So here's my y-intercept. And of course, we did say it was going to be a dashed line. So let's dash our line. We're going to dash it. Dash, 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 dash. Do you like how as I get to the ends, like my line gets a little more wobbly? We're going to keep dashing our line. Whew, look at us. Last but not least, which side do you shade, people? So let's plug in some zeros here. 2 times 0 minus 0, is it less than 4? Well, 2 times 0 is 0, and 0 minus 0 is 0. Yeah, 0 is less than 4. Great. So that's a solution. So we're going to shade the side with our origin. We're going to shade everything on that side. We're going to go crazy here. Do you do this like when I color? I like to kind of follow the line and then I go crazy. I actually maybe followed the line a little too close there. Then I can go crazy everywhere else. Whoa. All right, not my best shading job ever, but it's shaded. It's good. We got there. We got there. All right. So hopefully you're figuring this out. Now, previously, you've written a linear equation given various representations, including you've done it with 2 points. Like we just did it with 2 points, right? We had an x-intercept and y-intercept. We've written linear equations with a slope, with a point and a slope, maybe with a table of values. But the idea is if you can find the y-intercept, if you can find the slope, you can write the equation. And sometimes they've even given us a graph to help us write our equation. So we can use a very similar approach when writing a linear inequality. Let me show you what I mean. So here I have a graph, and we're asked to write a linear equality for the graph. So first thing I notice is that we have a y-intercept at -5. And if I pick another point, and actually I'm not going to pick that point. I don't want to pick that point. I'm going to pick a point to the right. That tends to work better, I think. So if I pick another point, like here's another point on the line, I can see that I had to go down 3 and over 2. So it looks like my y-intercept is 5, or pardon me, a -5. And it looks like my slope is down 3 over 2. So that helped us we know that our boundary line is the equation y equals -3/2 x minus 5. Now, we need to know which side to shade it on. So since the graph shows a solid boundary line, I know it's going to have a squashed equal sign. And notice that the half plane that we shaded is above it. Do you see if you were to pick a point, the shaded is above? So that means that y should be greater than or equal to -3/2 x minus 5. If it had picked a point on the line and it was shaded below, that would be a less than or equal to instead. And if you're unsure, you can always test it. You can pick a point in the shady side and plug it in and see what happens. So you can always test it. And again, we usually like to use 0, 0. So you can always plug in 0, 0 to see what happens. So they plugged in 0, 0 here and they're like, oh yes, 0 is greater than -5. So we did good. So I would like you to write a linear equality for each graph. This is the last thing we're doing, by the way. So parts A, B, and C for each one, can you write a linear inequality for each graph? I think you can do it. Go ahead and hit pause, write your inequalities, and then hit play when you're ready to check your work. All right, first things first. I see a y-intercept at 2. That's good to know, right? I'm just using that whole y equals mx plus b, baby. We're just going right back to it. I see a y-intercept at 2. So I know I've got a +2 hanging off the end. Let's find a slope though. Here's a good point. There's a good point. So it looks like to get to that point, I had to go up 1, 2, 3, 4 up and over 1. So it looks like my slope is 4 over 1. Oh, well, that's just 4. So I'm going to say 4. Now, I notice it's a dashed line, so it's not equal to. It looks like, though, if I pick a point, it's shaded below. So that, to me, says it's shaded below. That, to me, says it should be a less than symbol. So we're going to say that y is less than 4x plus 2. Dun, 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 dun. Hooray us. How'd you do with B? So for B, I can see that my y-intercept is at a -3. That's important to notice. So if I were just to write this as a line, I got a -3 on the end here. Let's check out our slope. I see another point right there. So it looks like to get to it, I had to go up 1 over 2. So it looks like my slope then is 1/2. Now, I notice this is a solid line. That's important to notice. So it's a solid line. So that means it should be equal to. So that's important. It looks like I shaded above, right? If I were to pick a point, I shaded up above that point. So that means y should be greater than or equal to 1/2 x minus 3. One more. Are you ready for one more? Can we do one more? Can we do one more? Let's do one more. Helps if my button goes the right way. All right, I see a y-intercept at -2. That's important. So I'm going to put a -2 on the end. My slope. Oh, we need to find a point. Here's a point. That's a good point. So it looks like to get to that point, I have to go up 1, 2, 3. I have to rise 3. And then I have to run 4. 1, 2, 3, 4. So it looks like my slope is 3 over 4. I notice this is a dashed line. So that means not equal to. That's important. I also notice if I were to pick a point on the line, I'm shaded below it. So since I'm below, that says to me that's a less than. So y is less than 3/4 x minus 2. Woo! Do you feel like you got a workout today? Because I feel like I got a workout today. As always, I hope you found this helpful and I hope you found this useful. If you've got questions or concerns, feel free to email me, or of course, even better yet, hit that little ask for help button in the Zoom meeting. Let me know you need help. I'll come in and check on you. And of course, I'm always available during office hours. I'll see you soon, guys. Bye.